Okay, hello everybody. Welcome to Circle Theorems Lesson 2. Thank you for everybody for your feedback from Circle Theorems Lesson 1. Lots of good feedback. The main thing there really was that the video was a bit blurry, so we're going to try and sort that out today. Also today we're going to do this in one shot, so if there's any little mistakes in there, we're just going to have to run with it. Okay, so plan for today, quick retrieval exercise. We're going to go through some more of the circle theorems, and then we are going to do some problem solving questions a little bit later on. There's a bit of an extension challenge in there as well for when we get to that bit. Right, okay, let's go. You might remember from last time that we are looking at 8 circle theorems, and we looked at these first 3 in the last lesson. So what I want you to do now is pause the video, get a piece of paper, get a pencil. We want you to sketch 3 circles, and we want you to sketch the 3 circle theorems from last lesson and try to remember what we called them last lesson. It's really important that you do this bit now and you don't just continue with the video. Okay, you need to spend a couple of minutes just trying to retrieve that from your memory. If that means you have to go back to your notes from last time, that's absolutely fine. Okay, so pause the video now. Okay, let's go over these really quickly for you then. We're going to go over these super quick. If this is too fast for you, you need to seek some support, email us. First one was the tangent and the radius. Tangent just touching the circle, radius from the centre, makes a right angle. Number 2, chord and radius. Chord, radius, right angle there, 2 equal lengths. Number 3, 2 tangents. There to there, and there to there, equal. Okay, that's from last lesson. On to the next 3 circle theorems 4, 5 and 6. Number 1, we're going to call this, number 4, we're going to call this right angle in a semicircle. Radius, another radius through the centre makes a diameter. You can see the semicircle forming now. So if I make a triangle inside that semicircle, what's important to know here is that that is a right angle. Now that will always be a right angle. I'm going to just work backwards now and show you that even if I was to go over here in a completely different point, this angle here would still have been a right angle. That's the circle theorem. Okay, that's it for that one. Number 5, cyclic quadrilateral. Quadrilateral, as you know, 4-sided shape. For this one, I'm going to take 4 points on the circumference of the circle. I'm going to try and be as random as possible. And I will connect these up like so to make quadrilateral. And what we can take from this, if I call this A, B, C, D, these 2 angles, the opposite angles, will add up to 180 degrees, always. Same with these 2. So I'll write that here. Okay, when you're sketching yours, maybe play around with that one, draw some different quadrilaterals. They will always, the opposite angles will sum to 180 degrees. Okay, number 6, we're going to call this arrowhead. That's just a little bit of a nickname for now. There is a more complex name to come later on, but right now we're just going for these sort of quick nicknames to make it easier for us. Okay, radius here, radius here. That shape is a four-sided shape that we call an arrowhead. And what we need to know from this is that if we call this angle x, then this angle here at the centre will be 2x. That angle is twice as big as that one, or that angle is half the size of that one. Okay, I'm just going to reverse a second, because what's really important to know about that one is that no matter where I put that point, whether I was to put it here, or even down here, that would still be true. For example, even if I was to go to here, this was my 2x from before, this bit here. This bit here would now be my x. A little bit more complicated when it looks like that. So for now, we will just stick to drawing it like this. Okay, so there are circle theorems 4, 5 and 6. On to some problem solving questions now then. Okay, we have 2 problem solving questions for you. Here is the first of the 2. Might be a good idea to pause the video at some point during this to give yourself a chance to have a go at it. Right, so we'll give you a little bit of help. You're going to use 2 circle theorems to find the angle x here. The first one that you will use will be from last lesson, and the second one you will use will be from this lesson. Good time to pause the video now for a couple of minutes. Okay, so hopefully you spotted that the first circle theorem to use here would be the tangent radius. Okay, so the reason for that is because this is the information we've been given, the 40 degrees. So these 2 tangents here are going to give us the first bit of information. Now, they might not look like tangents to begin with, but you know, these lines would continue forever. They would be tangents there, and the same on that side. So what does that tell us? From the tangent radius theorem, we're going to get a right angle there, radius, right angle there. Okay, now that's helped us because we have a kite shape here, O, F, E, H. 2 90s and a 40 make 220. So this will be 140 degrees, so that the 4 angles make 360 degrees. So the second circle theorem that you would use will be the arrowhead theorem from this lesson. You can see H, O, F, G makes that arrowhead shape. Really important that we're going through the centre there. So this angle here will be half of this one here. So X will be 70 degrees. Well done if you got that. Let's go to question 2. Okay. There's a lot going on here. So obviously we're going to have a look first at what information we might use. It might be tempting here to use circle theorem 4, which is the right angle in a semicircle, because you can see here that we've got diameter. But this diameter doesn't make up a triangle anywhere. The full diameter itself doesn't make up a triangle anywhere, so that one's not going to work. We do, though, have 4 points on the circumference that make a quadrilateral. that's going to be useful. Also remember from last lesson, we talked quite a lot about radii. When we've got more than one radius, they will be equal in length. There's a lot of information we can get out of that. Good time to pause the video now and have a go at this question. Okay. Okay, so we'll talk briefly about the radii. We've got one here, here, and here. They will all be equal in length. So surely this information will be useful now. We've got an isosceles triangle here, so these two base angles will both be the same. From that we can then work out this angle. Just doing that in my head. 56 degrees, give me a nod, miss, if that's right. Yes, okay. So there's lots of ways we could take this next bit. We could go different ways. You might have gone a different way. The way that we are going to look at this now is using the cyclic quadrilateral theorem. This angle here and this angle here are opposite angles in the cyclic quadrilateral. So these two here must add up to 180 degrees. So I'll take that from 180, 118 degrees. So well done if you managed to get any of those two right. Only 2 problem solving questions for you today. You have a task set up on Active Learn. Just one little extra bit today, a bit of an extension there for you. Whenever I teach this to my students, I always get some students that realise after a little while, maybe after a few lessons, that Circle Theorem 4 and Circle Theorem 6 are actually quite similar. In fact, mathematically, they're actually kind of the same thing. If anyone can explain to me why that's the case, drop me an email. I'd be really impressed with you. Okay, so just to summarise, we started off by retrieving the circle theorems from last lesson. So I'm sure you can guess next lesson, the first thing I'm going to ask you to do is draw the 6 circle theorems and their names. So keep practicing that, get them stuck up around your house on post-it notes or whatever. If we can learn the circle theorems, everything else is easy. Then we went through those 3, then we did some problem solving questions, and I look forward to reading your emails regarding the extension. You've got a task over on Active Learn. Thanks for listening. Drop us an email if you need anything at all.